Hello everyone, this is Nirmala Thurve. So in previous video, we already studied about the factory pattern, abstract factory pattern, single tone pattern. Now we'll study builder pattern. It is very useful pattern in which we just try to use a concept which is used by real builders. Means when they are building a particular architecture, that time they are using whatever approach we are using same approach for our software as well. So see the definition: builder pattern builds a complex object using simple objects and using a step by step approach. This type of design pattern comes under creational pattern, as this pattern provides one of the best way to create an object. A builder class builds the final object step by step. This builder is independent of other object. So you can understand by the definition. The definition says builder can create a complicated architecture, but when we are just going in detail, that time we found out that the particular complex architecture is a set of small simple architecture. So just like that, when we are creating a complicated software, that time also we need to use a simple object. So when we are creating a complex object which is actually built by the simple object, so that is the very important concept about the builder pattern. When we are creating something very complicated, it means it is a form by the simple objects itself. Okay, so that one is a builder pattern in which we are explaining the particular diagram in which there is item mill builders which is providing a simple food items and their packaging. So first step represent create an interface item representing food items and packaging, and the second one create concrete classes implementing the package interface, and then third one create abstract classes implementing the item interface providing default function which is by default we have to use it. Now we can see the fourth step in which it's represent create concrete classes extending burgers and cold drink classes. Now the step number fifth, create a meal class having item objects defined above. Now the sixth one, create a meal builder class. The actual builder class responsible to create meal object in which a burger and plus the cold drink or whatever drink we are providing, both are these a combination of the meal builder class. Okay, step number 7, builder pattern demo uses meal builder to demonstrate builder pattern. So eighth step is verify the outputs. Okay, so that one is what? Builder pattern in which we are using simple object to create a complicated object. So that is very useful. Now the next one is prototype pattern. Prototype pattern refers to create duplicate object while keeping performance in mind. For example, when we went to the a particular shop, that time the person who want to attract our customer, they provide already a demo objects or demo products, so we can choose our idea, we can tell them our preferences. So it is very easy to make understand what we want and what they can do for us. So it is a prototype pattern. So see the definition first. Prototype pattern refers to create duplicate object while keeping performance in mind. This type of design pattern comes under creational pattern, as this pattern provides one of the best way to create an object. Of course, they have already predefined designs. It means the time may be consumed less than if we are creating a new concept. If they have demos, if they have prototype, it means just like a menu card. When we went to the hotel, that time the hotel provide us a menu card and we can select our dish. Same as here also, they are providing some demo kind of number of design and we can choose anyone. That one is a prototype pattern. Okay, see, this pattern involves implementing a prototype interface which tells to create clone means a duplicate version of some object. Okay, clone of the current object. This pattern is used when creation of object directly is costly. For example, an object it to be created after a costly database operator. We can take an example of cache memory. If we are fetching some variable from the hard disk, it will take more time. So for that we are preferring fetch data from the cache memory. So this is the way to save our time. So that one is the one. If we are fetching a particular data from the hard disk, it is very time taking, so it will take longer time. So we just prefer to search first in a cache memory because it is the fastest memory as compared to hard disk. So same concept we are using in here also. If our object is very costly, then we can just create a clone for that object. So it will save our money or cost in terms of time and in terms of money also. So that one is a prototype pattern. Okay, the implementation of prototype pattern, we are going to create an abstract class shape and concrete classes extending the shape class. A class shape cache is defined as a next step which stores shape objects in a hash table and return their clones when it's requested. Okay, and prototype pattern demo, our demo class will use shape cache classes to get a shape object. Whenever object is requested, that time we are not creating a new object, we are just fetching the same objects clone. So that is the procedure to get the particular implementation of prototype pattern. So move further. Okay guys, the next one is adapter pattern. You know what is the adapter? If two different parties wants to communicate to each other which is not able to communicate directly, so they need some bridge in between both parties. So this same concept we are using is here. So see the definition. Adapter pattern works as a bridge between two incompatible interface. This type of design pattern comes under structural pattern as this pattern combines the capability of two independent interface. So we can understand by the definition, there is two different interface which is not able to communicate directly because they are independent, and so for that we need some pattern which is making a bridge between both interface. See further, this pattern involves a single class which is responsible to join functionalities of independent or incompatible interface. A real life example could be a case of card reader which act as an adapter between memory card and a laptop. So it is a very good example because we people very familiar about the laptop and the memory card. So we can understand what is the use of adapter. You plug in the memory card into card reader and card reader into the laptop so that the memory card can be used via laptop. So we can understand the what is the importance of our adapter. So this is a very good example to make understand what is the adapter pattern. So the next pattern is bridge pattern, which is a little bit different from the previous one, because there we are providing a bridge to combine both classes which is not able to combine. So here there is just vice versa. See the definition. Bridge is used when we need to decouple. There we just want to couple, and here we just want to decouple an abstraction from an in implementation, so that the two can vary independently. So there is a one interface or one set of class, and we just try to decouple that. We just try to isolate both classes from each other. That time we use a bridge. Okay, bridge pattern. This type of design pattern comes under structural pattern, as this pattern decoupled implementation class and abstract class by providing a bridge structure between them. So you can understand the bridge concept we are using here, but not for the coupling, for the decoupling. This pattern involves an interface which acts as a bridge, which makes the functionality of the concrete classes independent from the interface implementation classes. Both type of classes can be altered structurally without affecting each other. Means we can alter one class, we can alter other class, but both class will not affect to each other. So that one is a concept of decoupling, which is we are using in a bridge pattern. Okay, the next one is composite pattern, in which we can say this is the combination of number of different classes or objects, and we'll consider that one is a single object. So just see the definition. Composite pattern is used where we need to treat a group of objects in similar way as a single object. Composite patterns composes objects in terms of tree structure to represent part as well as whole hierarchy, whatever you can understand, whole hierarchy. This type of design pattern comes under structure pattern, as this pattern create a tree structure of a group of objects. This pattern creates a class that contain a group of its own object. This class provides a way to modify its group as same object. Okay, we can demonstrate use of the composite pattern via following example, in which we will show employees hierarchy of an organization. So we consider the implementation of the organization. We have a class employee which act as a composite pattern actor class. Okay, and composite pattern demo class, which will use employee class and at department level hierarchy and print all employees. So we can see there's a two classes. First one is a composite pattern demo, and second one is when we need a particular employee list, that time we need to use both class, and we consider that one is only a set of one object. It is not a set of object, it is a single object. Now see the next pattern, decorator pattern. Decorator, by the name we can understand, it is just like we are purchasing some gift and we just try to decorate it without changing the gift. So that one is the same concept here we are using. See the definition. Decorator pattern allows a users to add new functionality to an existing objects without altering its structure. This type of design pattern comes under structure pattern, as its pattern act as a wrapper to existing classes. This pattern creates a decorator class which wrap the original class and provide additional functionality, keeping class methods signature intact. So here we are just providing same object, we are adding with the some additional feature, but we are not altering the existing features or existing structure. So that one is the decorator pattern we are mainly use for when we are just modifying according to customer requirement. For example, name, means designs, colors, this kind of changes we are making changes here in decorator pattern. So that one is a very useful and very easy to use. So now next one we'll see in the next video. Thanks for watching.